Hello, my name is Peter Siri, and tonight I'm going to demonstrate a hypothesis test using a correlation statistic while analyzing the trends in neural information processing systems over the past 30 years. In this case, I want to determine if there's a really strong correlation between the annual increase in NIPS publications and the overall improvements in computer technology. To do this, I imported a data set which contains more than 50,000 research papers that were published over the past 30 years. I then grouped these papers by year and created two plots which visually show how much the publications have increased exponentially. And these visually, they really indicate that machine learning has been widely discussed more now than it was discussed 30 years ago. And this is largely attributed to the overall improvements in computer hardware as well as the efficiency of our algorithms. For me to infer one of these attributes, particularly the computer hardware attribute, I then have to import another CSV file which contains a list of the floating point operations per second that have been observed for each passing year. I then create another plot which also indicates the exponential increase in flops that we see over time. And that raises my confidence in determining that correlation between the increased computer speed and the increased number of NIPS publications that we see every year. So now that we have another variable to work with, we can create a new data frame storing both the NIPS publications variable and the flops variable as if they are ordinal pairs. And we can see conveniently that they are listed in ascending order, which highly suggests a positive relationship between the two variables. But we're going to go a step further by choosing a random sample of 20 of these ordinal pairs, and then creating a histogram for each of these variables to determine their normality. As we can see, they're not normally distributed. So that narrows down what kind of statistic we're going to be using for the hypothesis test. Beforehand, we're going to see what that relationship looks like by using a scatter plot. And what we see down here is that there is a monotonic relationship between the annual NIPS publications and the floating point operations observed each year. So while it's not a perfectly linear relationship like we see in the yellow line in this plot, we can see that it's always ascending. So there's a monotonic relationship between the two variables. It's always just going up. It's never going down. What this allows us to do is use Spearman's rho for our hypothesis test. And so we had to start with two assumptions. One is the null hypothesis, in which Spearman's rho is equal to 0 and that there is no correlation between the rate of NIPS publications and the observed flops every year. The alternative hypothesis, our second assumption, would be that rho is greater than 0 and that there is a positive relationship between the two variables. To find out, we're going to have to start finding rho first. And there are a couple of ways for me to do this. The one that I find most convenient only requires 2 lines of code. And the first line merely involves me importing the Spearman's R function from the scipy.stats package right over here. The second line merely involves me printing the results of the Spearman R function, which has the parameters of both the NIPS random variable and the flops random variable. And with just these 2 lines, I already have the correlation coefficient of roughly 0.976, and already I get the p-value of 2.12 to the negative 13. With all this here, I can conclude that I can reject the null hypothesis because this p-value would be far less than my chosen alpha value of 0.01. And I can say with 99% confidence that there is a positive correlation between the increased NIPS publications and the increase in computing speed that we observe every year.